So for this question, this is question 8C. So before we start on this question, let's look at the prior results from A, B, part 1 and part 2, which I think you all don't have to, didn't require me to make a video, right? So prior results from A, B, part 1 and part 2, just to remind that this is question 8C, so this is the second part of the question. The earlier results enable us to say that AQP and CQR are congruent. This was the result from part A. And B part 1 allows you to say that APQ is similar to ACD. And APQ is also similar to CAB, right? And also the ratio of AP to AD is 5:8. So let's look at C part 1. Okay, we want to look at the area of APQ to PDQ, right? So because these two triangles are congruent from part A, I'm just going to highlight them using the same color so that you can still see them here, the relationship. Now let's look at our main characters for part 1, right, which is APQ and PDQ, right? Because we know that the ratio of AP to AD is 5:8, right? So the ratio of AP to PD will also be 5:3, right? This is 8 units minus 5, this will be 3. Now if you observe this triangle, right, you can see how these two are actually triangles of the same height, right? I can use this as the height, and you can see that this black dotted line here can serve as the height for APQ as well as the height for PDQ. Alright, so what are we looking at here is this concept is asking you about the triangles, okay, for triangles of the same height. And so take note that this is asking you, testing you on the concept, or asking you to observe and identify that these two are actually triangles with the same height. So for triangles with the same height, what is the area ratio? The area ratio will just be the base ratio, right? The ratio of the area will just be the ratio of the base. So the area of triangle APQ over the area of triangle PDQ will just be the same as the ratio of AP is to PD, which is the same as 5/3. So that in itself will solve part 1. Okay, now let's look at part 2, where we are looking at PDQ over ABD. Now ABD is over here. Let me highlight it in green. Now this is ABD. Okay, ABD versus PDQ. So ABD here is highlighted in green, and PDQ is highlighted in red. Let's take a look at that. So when we observe this, right, we know that somehow these two triangles may, not really seem related. So I ask myself, ABD, is it related to anything else? So ABD, if we cannot find a relation between the two, we try to find interbridging triangles in between. So ABD, what can it be related to? We know that it can be related to from earlier. Okay, so don't have. ABD is probably related to can be related to DAQ, right? So why is it related to DAQ? Is because again there are two triangles with the same height. So what I want to observe and I want to show you is, if you observe that triangle ABD and triangle AQD, they has the same height, right? And also, right, we are talking about rhombus, so DQ is equals to QB. The ratio is 1:1. So if I'm talking about the area of triangle ABD to the ratio of area of triangle AQD, this should give us 2:1, because these are two triangles with the same height. Now note that, let's say if I were to draw this as the height, right? You can see that this red dotted line here serves as the height can serve as the height for ADQ as well as the height for ADB. Okay? So because this DQ and QB has the same ratio, right? Because they are both equal. We're talking about rhombus. Okay, so 2/1. Okay, because this is the same as basically DB is 2 DQ. Alright, so from here, what next is I can also look at AQD, alright, to ABD, PDQ. Now if I look at AQD, sorry, which is the one in gray, over PDQ. Again, this AQD and PDQ also has the same height. So if I look at the area of triangle AQD is to the area of triangle PDQ, this is the same as AD is to PD, which is 8:3. Right? So again, you can see that the connecting triangle between both ratios, alright, is AQD. So if I were to write out both, seeing how the area of triangle ABD to area of triangle AQD and area of triangle AQD to the area of triangle PDQ, we know that here this is 8:3. At the same time, this is ABD is 2:1, right? So what we might want to do is want to make AQD the same on both sides. This is 8, this is 1, right? So if I can ensure that these two are the same, then I can actually compare ABD to PDQ. So I'm going to multiply this by 8. I'll call this 8:16. So I want you to see that if I can make ABQD the same unit on both sides, then this is a good comparison for me to do, compare ABD and PDQ. So with that, right, we can say that ABD compared to PDQ is, okay, basically 16:3. So with that, I get my answer. This answer over here is just 16 units over 3. So the area of triangle PDQ represents 3 units and the area of triangle ABD will represent 16 units. Okay, so that is part 2. Now let's look at part 3. So for part 3, if I want to consider APX, okay, so where is X? X is a point on AC such that PX is parallel to DC. So I'm going to probably just erase everything so that it doesn't look so messy. So I draw a PX here. Draw a nicer line. PX here is parallel to DC. So now if you consider this triangle APX versus AQC, this is just a classic example of similar triangles, right? So of course, what you might need to do is take the time to prove that these two triangles are similar. So angle PAX is the same as angle DAC. Okay, again, this is called common angle. Alright, because these two are parallel, you can also conclude that angle APX is the same as angle ADC. Again, these are corresponding angles and PX is parallel to DC. So therefore, I can conclude that triangle PAQ is similar to to triangle DAC, because I have two pairs of corresponding angles which are equal. So once we talk about similar triangles, and remember that when they ask about area ratio, right, of triangles, it's either talking about triangles with the same height or triangles which are similar. So for triangles which are similar, the area ratio is just the square of the side ratio. So if we talk about the area of triangle APX over the area of triangle ADC, we can simply conclude that this is the same as AP over AD square. Okay, let me write it properly here. This is a bit messy. This is AP over AD square, because we are talking about these two triangles which are similar. Therefore, the area ratio is the square of the side ratio. Now, this is just 5 over 8. I remember just now this was 5 units. This was 8 units as stated by the question. Over here, which is the same as 25 over 64. And that's the answer for part 3.